Hello. Today we will talk what is science and what is research. The concept of science. The concept of science has several basic meanings. Science is a field of human activity aimed at the development or systematization of new knowledge about nature, social thinking, and understanding the world. Science is a result of such activity, a system of obtained scientific knowledge. Science is one of the form of social, considered social institute. In this sense, it is a system relationship between scientific organization and the members of the scientific community. It also includes systems of scientific information, norms, and values of science. The immediate goal of science are obtain knowledge about the objective as subjective words and compensation of objective that. The task of science: collection, description, analysis, generalization, explanation, effect. 2 points: discovery of a level of monitoring of nature, society, thinkings, and knowledges. 3 point: systematization of knowledge. 4 point: explanation of the essence of phenomenon and process. 4 points: variating events, phenomena and process. 6 points: establishment of direction and form of practical use knowledge. Processing from the development of moving material from the lowest to the heights. He thinks our mechanics, physics, chemistry, biology, and social science. 6 main forms of motion of matter: subatomic, physical, chemical, molecular physics, geological, biology, medical, scientific, depending on the field, subject, and the methods knowledge. This is science: physical, mathematics, chemical, biology, geological, technical, agricultural, historical, economical, philosophical, medical, pharmaceutical, veterinary, art history, architectural, physiological, military, national security, sociological, political, physical education, and sport is a part of our science for a very interesting direction for medicine, public administration, etc. What is science method? The scientific method is a process for experimentation that is used to explore, observation, and answer questions. Does this mean all scientists follow exactly this process? No. Some areas of science can be more easily tested than others. For example, scientists studying how stars challenge as they age, or how dinosaurs digest their food cannot pass forward stars live by a million years, or run medical exams on feeding dinosaurs to test their hypothesis. In frame of our course, we will repeat what is hypothesis, what is protocol of scientists work and researchers studied. When direct experimentation is not possible, scientists modify the scientific method. In fact, there probably is many versions of the scientific method as there are scientists, but even when modified, the goal remains the same: to discover cause and effect relationship by asking questions, carefully gathering and examining the evidence, and seeing if all the available information can be combined into a logical answer. Now, I want to show you small videos.
Science often starts with when we observe something and it makes us wonder. One way to explore the questions we have is to use the scientific method. The scientific method creates a framework for logically and systematically experimenting in order to find answers. It has several steps, including forming a question, researching background
It's a very
information,
interesting scale.
making a hypothesis, doing an experiment, analyzing data, and communicating the results. In this video, we will look at each step of the scientific method in more detail, using the science of popping boba, juice-filled balls that pop in your mouth, as an example. Formulating the question we want to answer is the first step of the scientific method. A scientific question usually starts with who, what, when, where, why, or how. The most
Dear my students, this question will be in your midterm and exam. You should know what is scientific questions: who, what, when, where, why, how.
most important thing about your question is that it must be testable. This means it needs to be something that you can do an experiment to figure out. So while you might be tempted to ask a general question like, how is popping boba made? This isn't a good scientific question. To answer that question, all you need is a recipe. Instead, choose a more specific question like, what kinds of liquids can be turned into popping boba? Or, what determines the size and shape of popping boba? With these more specific questions, we could experiment by testing different liquids, or by changing the process by which we make popping boba. Sometimes you can wonder about something but not know enough about the topic to make a question that is specific and testable. That's okay. If that happens, you can start with a general question, go on to step 2, and then come back and refine your question to make it testable once you know more about the topic. Step 2 is doing background research. In this step, we want to find out as much as possible about our research topic and learn from the experiences of others. When doing background research, we can find information in many different places. We can use books in the library, search the internet, or ask an expert or specialist questions about the subject we are exploring.
We have special lecture about searching of database system. Database system, a special website, official website, like as a library where we researchers and you students can go and search very interesting modern and the modern the best literature about our research questions.
Learning more about the subject helps us to find the best way to do things, gives us clues about what data we need to collect, or explains how to set up our experiment. In our popping boba example, we could research different popping boba recipes to find out what ingredients are necessary to turn juice into juice balls. We might also want to find out what the purpose of each ingredient is, what equipment is used, and what factors affect the ability of a liquid to successfully become popping boba. All this information will be helpful for the next steps of the scientific method. With the information we have gathered, we can move on to step number 3, which is constructing a hypothesis. A hypothesis is an educated guess based on background research about the answer to our question. A hypothesis always includes a prediction that is easy to test and measure. It's common for the prediction to take the form of, if I do this, then this will happen.
What is the hypothesis? This question will be in your midterm and final exam and in quiz too.
For example, based on the background research we did for our popping boba project, we learned that sodium alginate, a key ingredient in some popping boba recipes, only thickens in environments that are not too acidic. Thinking about how this might affect our popping boba, we might come up with a hypothesis that says, if I use liquids that are very acidic, then the popping boba's shape will be less spherical. Once we have made our hypothesis, we will test it by designing and carrying out an experiment. To do this, we first need to identify the variables of the experiment. There are usually 3 different kinds of variables. The independent variable is the one and only variable that is changed during the experiment. In our popping boba experiment, the acidity or pH of a liquid would be a good independent variable that we could change to investigate how acidity affects the shape of the popping boba. The dependent variable is the one that is measured during the experiment to determine the effects of the changes we are making. In our popping boba experiment, we want to know if the shape of the popping boba changes. Since good popping boba.
One moment, I want to tell you one very, very important note. All experiments we can divide it. Independent experiment and dependent experiment, and all researcher in the world we can divide it to independent research without institution and affiliation, and dependent researcher. My affiliation is European University, and your affiliation is European University too. We are dependent researchers.
Boba is considered to be spherical or ball-like in shape, we could measure the longest and shortest dimension or the diameter and height of the popping boba we make. It is okay to have more than one dependent variable. Controlled variables are all the other conditions in the experiment that we want to keep the same. In our popping boba experiment, the reaction temperature or quantities of each ingredient are some examples of controlled variables. By keeping all the controlled variables the same, we know that any changes in the height or diameter of the boba are due to the acidity of our juice instead of one of these factors. Determining the variables of our experiment helps us to come up with an experimental procedure or step-by-step instructions that will allow us to collect the data we need to test our hypothesis. A simplified experimental procedure for our popping boba experiment could look like this. Choose a liquid or food you want to test. Then follow a step-by-step recipe to make several popping boba balls. Measure the diameter and the height of each ball using graph paper. And finally, redo the experiment, but change the acidity of the food mixture. An important aspect of a scientific experiment is to repeat the experiment for each testing condition several times to make sure that the results are reproducible and not random. Make sure to carefully record everything you do, measure, and observe in a lab notebook so that you have a clear record of your experiment.
This writing text called protocol of experiments. We will talk about protocol and parts of protocols.
Taking videos, pictures, or making drawings is also a good idea. When doing our experiment, we need to actively ask, is the procedure working as we collect our data? If the experiment is not working, we will need to troubleshoot the procedure and restart the experiment. For example, we might find that it is really difficult to produce a single drop of food mixture using a syringe. This means that we have to rethink our procedure and then redo the experiment. For example, instead of using a syringe, we might try using a medical dropper. The goal of conducting the experiment is to collect enough data to confidently determine if our hypothesis is supported or not. The next step after we
Okay, I want to add some information. You can see graphs, yes. But now we have discussed about concretely experiments, yes. But when we will receive some results, we should present our results to the another students, other students, and to conference or an international boards, etc. There are some methods of present our results. First, text. Second, table. And number three, graphs. It's very important. Therefore, we can present our results with words, with text, with graphs, and with tables. Continue,
finish our
please.
procedure and have collected our data is to review and analyze our data. Analyzing the data means looking at it in as many ways as we can. This includes things like calculating an average for the different trials of our experiment, making graphs, and evaluating whether or not the collected data is complete, of good enough quality, and is valid. For our popping boba experiment, we could make graphs that show how the diameter or height of our popping boba balls change with juice acidity. In graphs like these, we usually place the independent variable on the x-axis and the dependent variable on the y-axis. It is important to label your graphs and results clearly and include their measurement units. If our data is sufficient, we can then draw conclusions about whether or not our data supports our hypothesis. It is okay if our hypothesis is not supported. This happens often to scientists. Sometimes the data leads to more questions, and the process starts again with a slightly different question and a new hypothesis. The final step of the scientific method is communicating our results. This means communicating all of our data and findings in a written report, oral presentation, or in some other way so that anybody who is interested in making popping boba balls can use our information to optimize their size, shape, and deliciousness. Now that you know how the scientific method works, you are ready for your next science adventure. Remember, though, that questions in some areas of science can be more easily tested than others. Don't be afraid to modify steps of the scientific method. For example, if direct experimentation is not possible to test your hypothesis, you could use a simulation or mathematical model instead. Just keep in mind that the goal of your investigation should be to discover cause and effect relationships by asking questions, carefully gathering and examining the evidence, and seeing if all the available information can be combined into a logical answer. If you want to practice the scientific method or need more information, visit us at www.sciencebuddies.org, where you can find thousands.
Even to show the scientific method as a series of steps, keep in mind that new information or thinking might cause a scientist to back up and repeat step at any point during the process. A process like the scientific method that involves such backing up, the repeating is called an iterative process. Whether you are doing a scientific fair project, a classroom scientific activity, independent research, or any other hand-on science inquiry, understanding the steps of the scientific methods will help you focus on your scientific question and work through our observation and data to answer the questions as well as possible. You can see a very nice picture from our video, and we will talk about this picture in the next weeks. And I want your attention on this slide because this slide is very important for you, for students, for us, for researchers, etc. Scientific questions are next. Who, what, when, where, why, and now. Thank you very much, my dear.